what are key characteristics of a function family? How can I identify a function family from a graph? So those are the two questions you want to be able to answer at the end of this lesson. So what is a function? Well, if we get into what a function is, you're looking at something that can pass a vertical line test when looking at a graph. So I can take, a couple markers here, make a vertical line, and at no point does this vertical line pass through two coordinates, two spots of the graph, then it's a function. If it does, then it's not a function. And I'll show you another way to tell whether or not it's a function, say you don't have a graph. The functions can be some more characteristics. So the first characteristic is it a function or not, right? And then a function can be discrete or it can be continuous. So a discrete function is when you just kind of have points and they're not connected. An example might be like if you're getting buses for a field trip, you can't get like half of a bus, so maybe you have like a discrete function where it's disconnected. A continuous function is where it's all connected together, like a line. All right, so again, if it's a function, you can use what's called an arrow diagram, where I might have three x values. And then I can put it in one circle, and make another circle where I put y values. As long as each x value only goes to one y value, you're fine. So if x sub 1 goes to y sub 1, that's good. If x sub 2 goes to y sub 1, that is still good. You can still have the same y value twice, you just can't have the same x value twice. If x sub 3 goes to y sub 2, you're fine, but say I were to say x sub 3 also could be y sub 1, this makes it not a function. As soon as one x value goes to two different y values, you no longer have a function. Increasing. So an increasing function, looks like I forgot. All right, so increasing and decreasing. If a function if the y values are going up as the x values go up, basically as x increases, y increases, it's an increasing function. It might look something like this line. Decreasing is the opposite. As you increase on the x values, your y values go down, so it might look something like this. Look at the difference between those two lines. It can also be both. Functions can change direction. So it could be decreasing up until this point, and then it starts increasing, or it can increase and then decrease, or it can go back and forth a few times, depending on the type of function. Four more characteristics here, some vocabulary to remember. You have your maximum, your minimum, your domain, and your range. The maximum is your highest y value. So in here, the one graph that has a good maximum is graph D. It goes up, stops, and then kind of goes back down. But keep in mind, a graph like graph A has no maximum. So it doesn't always have to have a maximum. So that's a characteristic. Does the graph have a maximum value? Does it not? Does it have a max or not? Minimum is the lowest y value. Again, A has a minimum. It has a lowest y value. D down here does not have a minimum. So graphs can have a minimum, they can have a maximum, they can have one, both, or none. They might not have any. So that's a characteristic you want to identify within functions. A domain is your possible x values. For example, these graphs B and C, B has a domain where x is less than or equal to 0. So it stops here, so your x values are all anything less than 0. Whereas C has a domain of x is greater than or equal to 0. So you have these two different graphs, B and C. They have two different domains, your possible x values. You can have a possible x value of all numbers, like in A. It kind of goes on forever in this direction and on forever in this direction. So all real numbers would be your possible x values in this. Range can be the same situation where you can have all possible y values, but let's take a couple examples. When you have a maximum and a minimum, you're going to have a cutoff range there. If you have both, your range will go basically from your maximum to your minimum. But say, for example, in D, where your maximum might be like here, so your range would be from this point, wherever that is, it's not labeled on the graph, and below. Say in like B here and C, your lowest y value is going to be 0, right here, the origin. And it looks like it's slowly increasing eventually, so it would be y is greater than or equal to 0. A would be y is greater than or equal to whatever this is, your minimum value here. All right, so we've talked about some major characteristics. We're now going to move into 5 function families that I want you to learn about. The 5 families are linear, quadratic, exponential, piecewise, and absolute value. Just get a general overview in this lesson. We'll study these more later this year. Linear functions are y equals mx plus b. Hopefully you've seen this slope-intercept form before. It's just a straight line. Quadratic is when you have an x value raised to, which is squared, raised to a second power. Generally is going to look what we call a parabola. You can put a negative in front of the x value and kind of flip this upside down or translate it in a variety of different ways. We'll study that later. Exponential is when the x value is in the exponent. So y equals b, or a base, raised to x. It'll just kind of be this curved line. And we'll study those more later this year. Piecewise is when you have different pieces. This one just has 2 pieces. So y equals, and you put these brackets, it's x squared such that x is less than or equal to 2. And it's x plus 1 such that 2 is less than x. So at 2, about here, it changes to x plus 1. And before 2, when it's less than 2, it's x squared. So the graph goes, stops, jumps here, and goes like that. There's a gap in this function, which you can sometimes have. That's looking like at discrete functions can have gaps, whereas continuous would not have any gaps. And that's just piecewise. You can have more than 2 pieces. You could have a ton of pieces in a piecewise function. Absolute value is when y equals the absolute value of an x term. Kind of looks like a little bit of a v in the parent function here, but it can be flipped upside down, rotated, or kind of translated and moved around as well. These are your 5 main function families and the characteristics we can use to describe and identify them.